Hello. So this is our lecture 3 on data structures using C++. Now, in this particular session, it's going to be a brief one. What we're going to cover is a little bit more on C++. What we did in our previous class, we just touched up on C++ without going much into detail. Yeah, it wasn't in any detail at all. We picked up one example of a rational number, which is again what I have in front of me. And what I plan to do is to be a little bit more professional about how we are writing this stuff here. Okay. And then along with that, we will also talk a little bit about object orientation. Not really a whole lot, because this course is not about object orientation. It also isn't really so much about C++. C++ just happens to be the language of choice here. Okay, but we will still need to know a little bit about this so that we can code in or implement our data structures, the ones that we learn. So yeah, let us have a quick look at what we had in our previous class. We had this rational number class, the new data type that we created in lecture 2. We have this constructor, we have an add method, and we have a print method. Okay, so this all starts right here within the class. Actually, that was a good thing to do. So we had this class, right? This data type, and everything is hidden right now. So we have this data type, and within this data type, there are some methods or functions we can use. So we can use the constructor to instantiate the values of numerator and denominator. And then we have this add method that lets us add one rational number to another rational number. Then we get a third rational number as output. And then we can also print them using the print method. So what I want to start off with, and since it's going to be more on C++, I want to make some certain changes, okay, within the code so that we can do this thing in a better way. Now, right off the bat, if you look at this implementation right here, okay, we have this definition of rational number. We have the constructor, we have the add method, okay, and we have the print method. Everything is here. But if you think of the class diagram itself, okay, within the class diagram, what we had in there, we had just the data members, the name of the data members and the data types, and along with that, we had the signatures of the methods. We didn't really think about the implementation at that point. So it really helps if we can have a declaration sort of the data type itself, and then the implementation or the definition of each of these methods, they can be somewhere else. I mean, the implementation specific details, they can be kept into something else altogether. So what really am I talking about? I mean, here we have the whole thing in one place, and it looks fine. But come to think of it, if your data type gets used in many different places, in many different files, why would you want to compile the whole thing over and over again? Okay, so let us imagine that we have, let me go to another page. Okay, let us think of this hypothetical scenario where we have this code for rational number. I'm trying to write it in a short form. Okay, let's say we have this code, and we have another file where we want to use this rational number. All right, so let's say we have a main, and I want to use this rational number code in here. So I can actually put the entire rational number code just like we did. We can create this class just like that, and put it in our main. However, let's say there is another piece of code, all right, that does all the math stuff. And there again, we need the rational number. So what we are doing here is that we are creating this class in two different places. If this is a part of the same project, the whole thing, if this is a part of the same project, this rational number thing, it's a single class, and its entire code only needs to be compiled once. But if you put it in multiple places, it's going to get compiled multiple times. And if you don't take proper measures, what is going to happen is that you're going to get compile time errors just because your class is being defined multiple times. Okay? So wouldn't it be nice, rather than having this thing in two different places, we still need to know that there is something new called rational number. So let us define this. Let us put the declaration aside. Like let us create the declaration in something called rational number .h, which is for the declaration. And then we can have another thing, rational number .cpp, all right, which is going to be the implementation of this header. Okay, so here we will have the declaration for the class, and here we will have the implementation of the class. Now, just to be consistent with the entire thing, for C we had header files with .h, and the source code or the implementation we had with .c extensions. So just to go with the flow, that all our source codes are ending with .cpp, and the header files, let's just say that they will end with .hpp. In many textbooks you'd see that they use .h, and I could go with that, but let me just follow this pattern. Not that I'm a really great advocate of this, but yeah, I'll just do this here. So what I'm trying to do here, I want to separate out the declaration of a class and the implementation of the methods in two different places. And eventually when we write our main, we will see that we only need to include the header. We don't need to include the implementation, the C++ file. We can compile them separately. We can have the C++ file, the rational number C++ file, we can have it compiled just once to create an object file, and then that can be linked together with the main to produce the final executable. Now, compiling, getting the object file, linking, these are a fair bit advanced topic which we probably don't know of right now. Fear not, we don't really need to know right at this point, but let's just say that this is a better design, and it makes our programming effort so much simpler because we can plan our data type. We can look at the class diagram, write our header file, and from within the header file we'll see what are the methods we need to implement, and then go and implement them in a C++ file. All right, so yeah, let's get on with it and see how this is done. Now, in our project, we got a main CPP. What I want to start off with, I want to add a new file. All right. So I want to add a header file, and it gives me that option. And I think, oh, it doesn't even let me do this with .hpp. It gives me an option for .h. I thought I could name it like that. Okay, so rational underscore number, and by default, since I'm getting .h, I'm not going to complain much. All right, so here we go. Now, since we're using a fairly advanced IDE called CLAN, some of these things we get for free. Otherwise, we'd have to do this by ourselves. This is a guard that you want to put in to keep you away from defining the data type multiple times. Okay, so if you put a if and def tag, I mean, you can call this whatever, right? It doesn't have to be rational underscore number underscore rational underscore number h. It doesn't have to be something like that. Why are they cutting off h at the end right now? I don't know. But what it really says is that if this is not defined, if this name is not defined, start defining this, and this is where the definition ends. Okay, only if this is not defined. If this is already defined, we're going to ignore this, and that's how it really helps the entire process. So what we are going to do here is we are going to write the class. Well, yeah, class is spelled with a CLA, I forgot that. So class rational number, okay, and within this, we need the numerator, we need the denominator, we need the denominator, and then we need some public stuff. We need them to be public by default because by default, everything in a class is marked as private. Okay, but I'd like to have this separation. I want to make this explicit. Previously, I didn't do that. I just wrote it as class rational number, and these things were private by default. That's why I didn't write them in that way. But I should mention that they are private. And the public stuff you can call from anywhere, like main or any other class or any other file in your project. You can do that. So for the public part, we need a constructor. And for the constructor, I want to pass the numerator and the denominator. Okay, so this is where you can name these things. You can name the parameters, or you can just say that I need 2 integers without giving the name. I think it's always a good practice to give them names. It makes documentation far easier when you just mention the types. Okay. One thing I want you guys to notice is that I'm using the same name. In our previous class, what I did is that I wanted to keep my life simple, and I used 2 different names. So for the parameters, we had num and den, but for the attributes, we had numerator and denominator. Now I want to go for that challenge, and I want to give them the same name because it makes more sense, right? And then for the methods, we have rational number. That's the return type. I want to write an add method where I will pass a rational number, and let's say that the rational number I'm passing, the name of the object is going to be b. All right. And similarly, I need a subtract method. I need a multiply method. I need a divide method. And well, yeah, this is going to be a little bit different. I need a reduce method, which reduces the given rational number and returns a new rational number, but in a reduced form. Okay, so you have to find the greatest divisor that can divide both the numerator and denominator. So that's that. And the last thing I think I added was that as decimal method, which gives you a floating point representation of the rational number itself. So that was pretty much it, right? That's our class. Now, if you define it in this way, we have this rational number .h. What we are going to do here, let me get rid of this altogether. All right. So this entire class that we have written here, I want to get rid of that. And of course, that we are going to have compiler. Now that we have taken that out, we're going to have compiler because this is no more defined. But as soon as you include the header, which in our case is rational number .h. Oh, I see why it says rational number like this. That was silly. That was really very silly. Let me rename this file. Somehow when I typed it out, I missed out this n. All right, so yeah, now it makes sense. And I guess that the file name was different, and that's why it it wrote it twice, or maybe it wants to write the name of the class first and then the file name. Well, this is something I'll figure out later. As long as it's the same thing. If it's not defined, define this and finish it off. So coming back to the main CPP, we got include rational number.h, and then you see that everything is fine except for the print method, right? So in this print method, this is not working because we don't have that. So at least we should have a placeholder which needs to say that the print method is there, and now it no longer complains. However, if you try to run this, it cannot work because we don't have any definition of these things, and that's why we have a linker error, because you cannot get the definition for the add method, for the constructor, or for anything else for that matter. So what do we do, right? We need to give definition for each of these things that are being used in main.cpp, at least. So what we are going to do here, we're going to add a new source file. And call this rational number.cpp. All right, so rational number and .cpp is coming here. And we could actually start right here with the source file and say that create an associated header file. That would probably be the better way to go about this. But since I already have the header file, I don't want to bother about that. So yeah, we got this rational number CPP. Now I want to include the same thing again because this is where I want to define all these things. So we got a rational number header file, we got a rational number source file, and the main where we are testing this out is in a separate place. This is the pattern we are going to carry on with every single time. If you're going to create a new data structure or a data type, we will have a source file, we'll have an associated header file, and anywhere we use this thing, we are only going to include the header file and not be bothered about the rest of the things. Okay. So what do we do in here? Well, this is the place where we are going to define each of these methods. So if you're thinking about the constructor, we're going to write that here. And if you're thinking about the add method, this is where we're going to define this. Let's start off with the add method. Okay. I'm going to steal my own code and implement this. Now, when you do this here, when you say that you're going to write the rational number add method, it doesn't really know that you're doing it for the header file that you included. Okay, it could be in another file where you have something about rational number and you're defining another add method there. How do you tell that you're defining the add method of the rational number class? This is what you have to indicate right in here by using the scope resolution operator. So you're going to say that the method that I'm going to define right now comes from the rational number class. So the name of the class comes first, then 2 colons. This is the scope resolution, and you can see that in our IDE we get the suggestions for autocomplete. That these are the possible options. We are only going to define the add method in here. How does the add method work? Well, again, I can steal my own code and take stuff from here and paste it right in this place. Okay. The same thing we can do for the print method because it's already here. Okay. Excuse me, but we haven't mentioned where this print is coming from. So again, rational number, scope resolution, and then the name of the method. So far so good, except for this thing right here, std. Well, how do we do this? This std it's a namespace and it's not defined anywhere. All right, so if we were to include IOStream where the cout and endl stuff are defined, and the namespace std is there, then it wouldn't complain. But yeah, since we didn't have that IOStream, it was complaining, and we fixed that just like that. Another thing it's complaining about, I used a different name here. We call rational number b. I thought we had a and b, but we don't. So I could go and do this in two ways. I can rename all these things to b, or I could just go here and rename this to y. Now, one thing you'd notice is that in this header file, we're calling it a and b. Well, not a and b, just b for the parameter. But it doesn't really matter when I come back to the actual implementation and I use a different variable name. It doesn't matter because it only looks at the data type itself and not the name of the variable or the object. Okay, so you can have a different name here. Although it is probably always a good idea to have the same name for the objects or the variables, because well, for documentation purpose, whoever is reading your code, they will otherwise get confused. So let me follow my own advice and do this here before I forget this. So we got the add method and the print method defined already, but we don't have the constructor, and without the constructor it wouldn't work. So this is where we can have the constructor defined. All right, and the sea lion from JetBrains is a really cool ID. It gives me all these suggestions, and all I need to do is to pick up the right one. So numerator and denominator, I could actually have the ID write the constructor for me, but I don't want to be that lazy, not yet. Okay, so let me do this in the proper way. What I want to do here is I want to set the numerator from here to the rational number class's numerator. So if I write numerator equal to numerator and denominator equal to denominator, that doesn't really make much sense, because the highlighter, it shows that the same thing is being highlighted. As soon as you pick numerator, all these numerators, they're getting highlighted. Okay, but this one should actually come from the class itself, right? So previously you noticed that we were using this reference. This is the pointer to the current object. So what we can do is we can write it in this form, this dot numerator. Now you see that it's different. When you highlight this one doesn't get highlighted, because this belongs to the class and this is the parameter that's coming in. All right, that's one way to do it. Or you could also use the arrow symbol, which means the same thing. If you're working with any pointer, rather than dereferencing that with an asterisk, putting a brace around it, which was probably, yeah, a little bit distracting, hurts the readability of the code as well. In C++, we have this new operator for working with pointers. If you're going to use a pointer to point to or to refer to any object, to get any data member from there, or to access any methods from there, you're just going to use the arrow, or you could also use the dereferencing using the asterisk symbol. It's just this one is far more readable, I think. All right. So at this point, let us try the same thing one more time. And now it works. All right, now it just works. So we got the header file, we got the CPP file, and we just need to implement these methods one at a time so that everything can work in one place. Okay. So as we go along, we can bring in more and more methods, and let me go for a really easy one. As decimal, if I want to represent a rational number as decimal, how do we go about this? Okay, we can simply do numerator divided by denominator, right? Plain and simple. So let's see what's the problem with this. Let's say I want to print out all these three rational numbers as decimal. Okay, so we have printed x, and I want to print, well, we got cout. We got to write std : cout, and then I want to get x dot as decimal, and I want to go for another new line, right? So that's that. Let me try this out. So it gets me 1 divided by 3 followed by 0, which shouldn't be 0. So that's something wrong to start with. But the one thing I want to fix before I even get there is that I'm getting sick and tired of writing std : for every cout, and for every endl I'm writing std : If I want to do it here, I'd have to do the same thing. Since this part is really common, and there is no way around without it, we can just say right at the top of our code, we can say using namespace std. All right, so the standard namespace that we have, if we say that we're going to use that, this gives us the opportunity to use this as a shorthand and forget about that. So no more you'd have to type that in, and I could do that right in here as well using namespace std. So yeah, get rid of this, get rid of this std here as well, and yeah, the code is a little bit more readable, well, actually simpler as well. So for x we can do this, for y we can do this, and for z we can do the same thing as well. Let me change this one and this one as well, and for every number I want to separate it out from the next number. So that's what I'm doing. All right, all zeros. How wonderful is that, right? So 1 divided by 3 gives us 0, 2 divided by 5 gives us 0, 11 divided by 15 gives us 0. Now what's happening here? Yeah, this is a common mistake, a rookie mistake at that. When you have two integer variables and you want to carry out the division operation, if it's all integer, it tells the arithmetic logic unit that you don't need any floating point calculation because it's a little bit slower. Well, no, it's a lot slower. Yeah. So if you know that both your parameters or the operands are integers, you no longer need to involve the floating point unit. You can just use the integer arithmetic unit to get the job done. The way you force the ALU to work differently is that you just send the signal and say that at least one of these things is floating point already. All right, so let's say that the numerator is a floating point number. Now it can no longer go for a total integer calculation. So with that change, we're now getting the right output. All right. I'm not talking about precision or accuracy here. This is fine as long as we're getting some double output. We can format that later and say how many digits we want after the dot. There is a really cool way to do it in C++. Well, we'll learn how to do it, but not right now. So everything that I talked about till this point is to make our code a little bit more manageable. If you look at main, it's so much simpler now because you don't have to define any of these things here. We have our new type called rational number. We have a source file for that here, and we have a nice little compact header file for that. So if someone needs to understand what your code does and what are the methods available, if you want to think of it as a library that's given to you, you only need to know all these signatures of the methods, how to call these methods, and probably you will get a nice little documentation that tells you what each of these methods do, what are the limitations, and exactly how it works. Well, in some cases, no, you don't even know how this thing works, but you just know that it works, right? This right here is a nice little savior, okay? Because we only need to know what we need to know. We don't need the extra details. The extra details is right here in the source, in the implementation of it. Okay, the implementation is of course important, but as a user, you only need to know what the class can do, what you're storing, and what are the operations you can perform here. This right here is a nice little example of a concept we're going to learn. It's called abstraction. Okay, so in all the data structures that we're going to create in this course, we're going to follow the same pattern. We will have a header file, we will have a source file, and then somewhere else we're going to test it out, or we are going to use this. Okay. Now, if you're coming from a competitive programming background, in most cases, the environment will ask you to put everything together in a single file and then send it to the judge. Okay, but that's a different story. But if you're working in a software firm, in most cases you would want to keep things manageable, reusable also. Okay, so this is where keeping this idea to separate out the header file, the implementation in a source file, and then using that somewhere else, it would be a better idea. Since I'm going to use clan in most cases and it didn't give me an option, I'll just keep it at .h. Probably it allows me to use .hpp, but yeah, I'll keep it at that. Okay, so yeah, that was a quick little rundown of doing nothing new except for the as decimal thing. We had the same little code that we had in our previous class, and I just split out stuff into multiple files for apparently no good reason, but yeah, for a really good reason. We'll come to know about that in a bit. So that concludes my first part of this lecture 3. Okay.